Hey, Dr. Zaidy and fellow alumni, MichaelDavid here. Today I'm going to walk you through a live demonstration of the Hybrid Vision Engine project for assignment 2.4. Before executing the model, I'm going to show you the project directory structure and active edge pipeline and how development interactions are backed up to ensure system stability. We have our hybrid vision engine.py. At the bottom, we have our inputs.csv. We have our run engine.bat. We have our outputs folder, and we have our old stuff. What I just demonstrated is our isolated projects workspace. We established a clean runtime environment where all active runs output directly to this folder, while our development history and fallback scripts versions 1 through 4 remain archived in old stuff as a rollback safety net. This builds directly upon the Edge AI architecture we covered in lecture. Local deployment, lightweight, and deterministic. Next, I'm going to open our inputs CSV manifest file to show how raw media targets are ingested into the processing loop and point out the string sanitization logic of our Python source. I just opened our input manifest and highlighted our ingestion block on lines 138 through 140 of Hybrid Vision Engine. In the backend code, this routine strips new line characters, carriage returns, and trailing space. Doing this ensures OpenCV's InRed function receive sanitized path strings and eliminates silent null pointer crashes before interface begins. Now, I am going to review the batch driver script, point out the confidence threshold of our Python engine, and launch the pipeline live by executing. This executed was our automated batch pipeline as seen on lines 4 and 9 of runEngine.bat. The batch script resolves system path variables to bypass window application aliases, verified our dependencies, instantiated the YOLOv8 small model at 0.45 confidence cutoff from line 65, and process each frame under the 100 millisecond execution threshold. Furthermore, on lines 121 and 122, each image array was written directly to disk and scored out of RAM immediately to prevent memory leakage. Next, I am going to show the visual overlay logic of our Python code and open our high-density urban transit output to inspect the resulting label layout. I highlighted our visual algorithms on lines 88 through 114 and opened output bus stop boarding image to display the result rather than letting default bounding box text collide across pedestrians sharing the same horizontal plane. Our code on line 88 calculated an alternating vertical offset using index modulo 2, combined with out-of-bound top canvas 91 through 94 and solid blue background badges on lines 97 through 114. All labels remain legible over complex background textures. Now I am going to cycle through our supplementary test outputs to demonstrate our high confidence detection, evaluate multi-scale vehicle registration, and analyze a critical failure mode involving small object scale and hand occlusion. Cell phone, cars. We just examined both primary high confidence success and edge unobstructed objects like the city transit bus and foreground pedestrians continuously triggered our highest activations scoring between 80% and 86% confidence. However, in person on cell phone, while the engine accurately detected the person with high certainty, it failed to register the smartphone. This illustrates a classic computer vision illustration. However, in person on cell phone, while the engine accurately detected the person with high certainty, it failed to register the smartphone. This illustrates a classic computer vision limitation. The user's hand partially occluded the phone's rectangular boundary, and the small pixel area dropped the detection confidence below the 45% cutoff threshold. Lastly, in our output cars, bounding boxes registration remained stable across distance scales, properly isolating nearby vehicles at 92% and distant vehicles at 45%, and cutting off vehicles below the confidence score of 45%. Next, I am going to open the generated analytical created by our plotting function on lines 36 through 53 of the script to review system-wide detection certainty. I open our detection confidence histogram generated from all logged candidate scalars across the batch. What this data shows is a pronounced right-skewed distribution where model peak lands between 81 and 85% with 11 detections, and over 52% of all detections fall into the high confidence 80% to 95% range. The lower scores reflect expected physical occlusions, while our 45% cutoff successfully eliminated false positive background noise. Finally, I am going to return to our project workspace to summarize our complete deliverable package. Vision.py, the runengine.bat file, the inputs CSV, the outputs folder, and the assignment 2.4 PDF. We just verified the entire end-to-end pipeline, automated dispensary resolution, sanitize, CSV, question, sub-second reference, adaptive visual rendering, and aggregated statistical analytics system is fully reproducible and meets all project requirements. Thank you for your time, Dr. Zaidy and fellow alumni, and I look forward to your feedback.